Hi everyone, so today we're gonna quickly review how you run a single group t-test using SPSS, and we're also gonna explore how you can actually calculate your confidence interval and also your cones D using an SPSS output. So just to briefly review how you run your single group t-test using SPSS. So here we have our problem. A developmental psychologist is interested in testing a new technique. Specifically, it's a different play group that they're using to see whether that actually affects the age at which children begin to speak. We know that in the population, the average age at which children begin to utter their first words is 13 months. So that is our mu. And so we're testing 15 children that we're putting in this new play group to test whether this new technique that they're using in the play group actually affects the age at which children begin to utter their first words. So here we have our 15 data points. So the first thing we would have to do is obviously open our SPSS software, and then we'll enter our data in the first column. If you click on the variable view, you can actually enter in a name for your variable. In this case, I named it age. Once you've entered in your data, you simply click on Analyze at the top, and then you move your cursor down to where it says Compare Means, and then you select one sample t-test, and then you will have another dialog box opening up that looks like this, and then you actually move your variable, in this case age, from this box and move it into the test variable box. And then also very important, don't forget that you're comparing your sample mean to a test value, in this case, right, our mu. So the average age at which children begin to speak in the population is 13. That's our mu. So we need to put our mu in this test value box right down here. If you don't put that value, it will use 0, and that's obviously incorrect. So you want to make sure you put your mu in this box before you hit OK. And because we're testing at the alpha level of 0.05, we don't need to change anything else. And then once you hit OK, it will calculate your single group t-test, and you will get this box. So this is our summary in the output box that you're getting. And this is basically where all the information is that we need. So the first box is actually our descriptive statistics. So we have 15 subjects in our sample. Our sample mean, our X bar, is 11. Then we have our standard deviation of our sample. And then we also have our standard error, which you know as S of X bar, which we typically calculate by taking our S and dividing it by the square root of n. But it's already given to you right here. And then where it says one sample test, referring to our one sample t-test, is where everything that we need is really located. So here we have our t obtained. In this case, it's negative 2.320. Then we have our degrees of freedom. And then we have our significance level. So this is our p-value. Again, when we're using SPSS, we don't need a critical value. We only need our obtained value. And the SPSS output will actually tell us our exact probability level. In this case, my p is 0.036, which is excellent because, as you can see right here, anything that is lower or equal to 0.05, we would decide to reject our null hypothesis, meaning that we're claiming that there is a significant effect. If my p-value is actually greater than 0.05, then I would fail to reject, and I wouldn't be able to say that there is a significant difference. So this is kind of like the first thing I always look to see if I actually have a significant result or not. Then the SPSS output also tells you the mean difference between the mu and the X bar. And then you also get a 95% confidence interval of the difference. So this is a little bit different from what we calculated in class by hand, because this is actually telling you how different the numbers are from the normal mu. So if you want to actually, rather than having the confidence interval of the difference, if you want to have our confidence interval that we calculated in class, that would tell you the age range at which children actually will begin to speak if they're part of this age group, you would have to do an extra step to calculate that. And I'm going to show you how you do that in just a moment. So first off, right, we need to think about what we need to write our APA style conclusion sentence. So we obviously need our T and our degrees of freedom, which I write here. Then we also need our p-value. And then last but not least, we need to calculate an effect size, either the Cohen's d or the confidence interval. So for both of those, we actually need to calculate some things by hand. So to calculate the Cohen's d, again, the formula is right here, and you should also have this in your notes. Your Cohen's d is calculated by taking x bar minus mu and dividing that by s. So we have all of that actually in our output right here. So we have our x bar is our mean. Then we know our mu is our test value, right? The average age at which children begin to speak normally. So we have 11 minus 13, and then we have our standard deviation right here. So you can solve for that and calculate your Cohen's d by simply taking those values and typing them into your calculator and calculating your Cohen's d. If you want to calculate your confidence interval, we have the confidence interval of the difference, but if we want to have the standard confidence interval as we've been calculating it in class, you would actually have to take your mu, right, which in this case is 13, and then you look at the lower and upper limit of the difference, and in this case they're both negative, so we have to subtract them from our mu. So you would take 13 minus the lower level difference, and that would give you one value. And then you also take the mu, 13 minus the upper limit, and that will give you this value. So in this case, right, I took 13 and subtracted the lower difference, and then I took 13 and subtracted the upper difference. So then our confidence interval is between 9.1514 and 12.8486. So what this is telling me is that I'm 95% confident that if a child is part of this new play group, that they will begin to speak somewhere between the age of 9 months and around 12 or 13 months. Okay, and then you can decide if you think that is a huge difference compared to the average of 13 months or not. So to write our sample conclusion sentence, this would be located right here. We can write something like, analysis revealed that the new technique significantly lowered the age at which children began to utter their first words. And I know that it's a decrease in age, right, because I have a negative t-value. So I know that it actually lowered the age, which is great, right, because children began to speak earlier. So I report my T of 14 degrees of freedom, which is right here. And then I report my exact p-value, right, because I'm not comparing anything to a critical value. I'm actually putting exactly what p is. And if it's lower than 0.05, I know that I have a significant difference. If it's greater than 0.05, then I know that it's not a significant difference. And then last but not least, I report my confidence interval. Okay, so for this assignment today, what you're asked to do is do exactly the same thing that we have done in this sample. You have two additional examples. One is located right here, so you go through the steps of calculating your single group t-test, and then you have to state your null and alternative hypothesis. And for this particular example, I'm going to ask you to calculate your Cohen's d. And remember that you only calculate the Cohen's d if you actually find that there's a significant difference. So only if your p is less than or equal to 0.05. Otherwise, that wouldn't be appropriate. And then you also report in a sentence what you found. And then you have your second example where you're asked to do exactly the same, except that instead of the Cohen's d, you will be asked to calculate your confidence interval. And again, this would only be appropriate if you actually reject your null hypothesis. Okay? All right. Hope the assignment goes well.